Hello everyone, and once again a warm welcome back to the DrMBalmer channel. Now, as you may see, I have quite a lot of stuff around here. But I've cleared up a bit on this area. Because this is part 4 in the series on the $12 or so US dollars equivalent solar lantern, and today we'll do the probably most interesting stuff, which you all have been waiting for. At least I have been waiting for. Yeah, let me just remove this because today, well, I have been using this outside, and it has worked fine. The large solar cell here has provided ample of charge power to the cell, but now that we are approaching well, autumn here, it's beginning of September, and well, that means shorter days, less sun, more rain, more clouds, colder. Everything gets more depressing. So I was thinking, this actually looks pretty nice outside, but as I mentioned in some previous part in this series, unfortunately this device does not come with any other option for charging the cell except, well, the solar cell. Yeah, that's what it's been bugging me, and that's why I got some stuff off of AliExpress. So we have a DC plug with some kind of plug in the end. Got well, all sorts of stuff. Let me pick one here, if possible. Maybe not. Maybe I have to. Yeah. So this is a USB-C female plug in a round connector with a JST connector in the other end, which I hope should be of the same size that it looks like it should be, like the ones found inside of the unit. Maybe we can do something with this, and then also there is, of course, like a nut. So I believe this should go inside of here, and then you fasten it. So I'm thinking maybe we could fasten a USB-C port. I mean, I don't think that rain should enter, but just to be on the safe side, I also have a similar bag, but which does have, oh yeah, that was pleasing, which does include these rubber dust covers, and in that case I suppose it should go there, and then once you fasten it like this, it will create a try to refocus. It will create waterproof seal here, maybe, but most importantly, it will fit into the USB slot itself and prevent not only rain but dust and insects and all kinds of stuff from entering. So yeah, I think this one will be interesting. And then so these are with the JST connectors, and this bag with the rubber or grommets or stuff are without connectors. So we'll see which one we'll need, but yeah, this will be a little bit of a project. And let's see here what else I got. I also got USB-C connectors of this kind. They're not round, but maybe these are harder to install because I can't drill a round hole. I will have to create a hole that's in this shape. But then I also have oops. Okay, I lost one. I have this DC plug, and yeah, so we could use a DC plug, of course, as well. But yeah, that's basically it. So the question is, I have a couple of questions. Well, here it is. I was looking for this one. I lost it. So I have a more decent DC plug. I only have one for some reason. This one with the rubber grommet as well. It should, yeah, it sits nicely. And then we will have oops, this nut. Yes. So I'm wondering which way to go, USB-C or... But one thing is the depth. So we can see here that the USB-C plug is not as deep as the DC barrel plug, and it all depends on how much space we got here. So the USB-C will, I mean, we have some space inside here, and the cable will, yeah, this should work. And then we'll also, but this one, yeah, the question is, this one is pretty, but yeah, it should fit as well. So maybe because one question that I have is oh yeah, because I also got some of these. We need these, I suppose. And these are can I refocus or zoom in maybe? These are USB-C battery, lithium-ion battery chargers modules. TP4056, I suppose it was written. It should be TP4056. We can have a look what it says here. So 10 pieces, 5 volts, 1 amp. So I didn't find any with a lower charge current than 1 amp. And I suppose one could change one of the resistors here or something to change the current, but as far as SMD soldering, I'm not too confident. I don't have the SMD components. They're very, very small, so I believe I would struggle a bit. And given that the cell inside of the unit, we measured it to be about a 1 amp hour cell, this would charge it at 1C, which, well, is maybe not ideal. I would rather charge it at 500 milliamps, sorry. But yeah, it should work. And then 18650, doesn't matter, I suppose. TP4056 lithium battery charger module, charging board with protection, dual functions, 1 amp. Yeah. Oh yeah, we have the text a little bit larger here as well. All right, so basically, using such a module, we should be able to charge the cell inside during the winter months, and to top off the cell and top up and yeah. So I think it would be hard to get this USB connector to actually protrude nicely from this case. So I'm thinking that therefore I will either cut off or use the version without the JST connector in that case, and connect them to these terminals here instead, and then charge the battery from there. So yeah, I had there I have the connectors without the USB connectors or headers. Without the JST plug. So oh yeah, and also I do have let's see here, I have another style which is okay, which did not want to open. With a micro USB instead, so if I'm not using the USB part of it anyway, I can use the micro USB version. So Yeah, because these ones are a bit smaller with a micro USB header, if that's a thing. So yeah, and then we also get hopefully charge protection, which would fix the issue here from the solar cell, at least. The question is then, should this device be on the inside of the unit or on the outside? Should I integrate it with the charging cable? I could, of course, like, for instance, I could create a cable. Let me bring. So let's say I plug this into a USB charger, and then I have my USB-C end here, and then I connect it to this module, and then I put this in a sort of a little box, and then I would have another cable going out from the box and into the USB-C header. So that would be one option, and this would be connected directly to the battery. But then you have to be sure not to connect a standard USB charger to it. Or if I use the barrel plug, I could create a barrel connector cable, which already, like from this end, with a barrel plug, and then connect this to the battery directly. I don't know. So using this outside will allow us to see the charge status. There are a couple of LEDs here, which should show when the battery is finished charging, and if it's on the inside, probably won't see it. So yeah, that's the question. Yeah, let me have a think, and we shall get to it. Maybe we actually will do two plugs, one USB-C and one barrel plug, in one case where this is inside the unit, and the other one with a standalone cable that actually is a charging cable with a barrel plug or something. So yeah, I will pause here and have a think, but now you know the idea. Alright, so first things first, let's open this device up once again. Okay, so there we have it. Right. So let's disconnect the lithium cell. And just put this aside for now. So what I would like to do is maybe if we can create a cable lead with let's see here, some connector, right? So let's say that we will use this. Unfortunately, I don't have this type of connector. This is a pretty large one. It's not the same as this JST, so maybe I have to cut this off and then we'll basically create a connector that fits this one. So a female connector. Maybe this should have like a Y splitter or something. If we open this bag up, yeah, so unfortunately these ones are more suited for mounting on maybe a PCB, which makes it makes it a bit difficult to make good cable leads out of them. So I have connected this soldering iron, and I will wait for it to heat up, and I will use this fan to get some fumes out of the way. This fume extractor. So it will make some noise, but maybe we'll cover it with some music or something. Anyway, so yeah, basically what I want to do is first of all grab some red and black wire, maybe create a cable with this connector on it. So yeah, let's get right to it. Maybe this length. Now I don't know if these, so 1 amp charge current at 5 volts or so, should be about 5 watts. I hope these leads are okay with that I don't need thicker ones. So first of all, just try to we'll try to create a charging cable just to connect this out here in the wild, so to speak, and see if it works. And I will strip these wires. There's someone outside cutting some grass or something. So I'm sorry if that noise is coming in here. Okay, so I have something looking like this, and hopefully it won't short out. I see I have some solder residue here that got stuck on it. Okay, so basically that would go to the cell like this. Yeah, and then let's connect it to this and solder it. And then we'll get a charging circuit, and we can just test charge the cell a bit and see if it all looks good. So yeah. So I will solder this, and can zoom in a little bit, maybe like that, and let me try to, yeah. So this one turned out better. This one, well, it's fine, I suppose. So let's cut these, and we have this set to volts here, and we shall set it to continuity mode, like this. And I want to make sure that we have continuity in the right places and not in the wrong places. And first of all, let's check the polarity. Battery plus is red, and then battery negative is black, and the red wire here will feed into the red wire once we turn this the right way around, like this. And so I want to probe this lead now. Check that the let's see here, positive wire has which is easier said than done. Positive wire has, okay, maybe yes, but not to the negative, I hope. No. And with the negative wire has continuity to negative. Yes, not to positive. Okay, so there shouldn't be a short. that's all good. And while we're at it, we do have the special cable we made. Why don't we use that? Okay, why don't we put, just to hold it in place a little bit better, we can put it here like that. And then without shorting anything, hopefully, if we connect the battery, it stays cool. That's good. And first of all, let's do a measurement on the voltage of the cell. So we should be able to grab this one, and I'm a bit out of shot. I see. This and that. 3.3114 volts. Well, yeah, I think that we shall connect this multimeter in series. Okay, I have fetched the alligator clip probes. I will put this red one in milliamps and the black one to the common. And we shall basically connect we shall put this to milliamps. What we have 1 amp max here, it says, so maybe I should put it to 10 amp max slot and measure amps in case it actually charges it in with 1 amp. And I will need this was the micro USB model, so I will need a micro USB sort of cable, so I shall fetch that. Okay, I have a micro USB cable. I will connect the USB type A end into my USB charger, and then this other end it should go here. And yeah, it's showing something, so I have to be careful here not to short anything out. So I don't know how visible it is, but yes, there is a red light. and it's showing 460. Oh, microphone. 460 milliamps. And it's decreasing. Yeah, 430 milliamps. And let's measure the voltage at the same time if possible. Okay, I have grabbed the other clamp meter, but I will use it for its voltage measuring capabilities. Currently, so it's good that it actually does reduce the charging current depending on the voltage of the cell, I suppose, so that we don't have 1 amp constantly, which would maybe be a bit much for the 1 amp hour cell here. So let's put this to volts, and I should be able to measure here and there. Yeah, 4.24 volts currently over the cell. Let's see here again. Yeah. So it seems like it's charging it, at least, so we have that working. Let's leave it for a little while and see what happens, basically. So yeah, if I unplug the USB lead from the USB charger, let's see what kind of voltage we have now. It has only charged for a minute or so, but 3.62 volts. Yeah, 3.6. Okay. So that's good. I will leave it a few moments longer charging. Right, so 10 minutes or so have passed, and we're down to 200 milliamps in charge current, which is good. And well, the voltage .17 it shows. So if I disconnect the USB plug and yeah, 3.775 volts. So we're definitely charging the cell, which is good, and everything seems cool and nice. Great. So adding the capability. Yeah, so adding the capability of being able to charge up the cell via USB, that's pretty neat, I think. Inside a unit like this, you can use it in the winter as well. And especially if you get a larger capacity cell, it will probably stay lit for a lot longer. But we'll start off with this one and just see if we make it at all, so to speak. So yeah, let's disconnect the cell and our special lead. So what I want to do is then the question being, do I want this inside the body of the unit itself, like having it somewhere in here, or should the charging cable be external to the shell and just have a, so in case this fails or something inside of the unit, I can't really see the red LED. Well, of course, I suppose if I could place it somehow, but I will, I mean, so that the light is visible when it's fully charged or not. Of course, I can monitor how much current is being drawn by using a USB current meter, but yeah. So maybe we should have both. One interface that is with this internal in the shell, and one that is external. But it may be hard to fit both solutions and create a lot of cable mess. Yeah, so I will have a think about that, and I will return once I have decided. Alright, I have given it some thought, and let's go full on this. So, meaning that we should have both interfaces. One which goes through this to the cell and then to the board. So we need to tap in. So, for instance, like this should go from the cell, and then also from the cell we need a connection not only to this board to get a charge, but also to this board to power the LEDs, right? And then we will have some input connected to these positive and negative input terminals, and that should be the USB-C, because that's more intuitive. If you actually plug in a USB connection, then it should be USB charging, so to speak. That's my idea. Less chance of an error. And then we'll add DC plug charging capability. So we'll create an external cable with this attached to it, and it should have a DC plug, so a male plug like this, and this will protrude from the bottom here, and then when you want to charge this end of the cable will have such a charging module, and then you already get the output. So from the output of it you have this plug, and then you already plug in a charger, so to speak. And it's a very tight fit actually, but it should work. Yeah, so that's the plan. First things first, then I need to cut open this wire here in the middle maybe, and tap in with the one wire that goes to this circuit board in parallel, so red to red and black to black, like this. And I won't do a connector here, I will simply solder it, I think, and heat shrink it. And then the output of this connector should also be in parallel here. And it will actually be two-way, because you will be able to tap the power from the cell from this connector if you want to. So yeah, so I will cut this open, and we shall I'll remove the cell for now from any heat sources, and I shall plug in my soldering iron, allow it to heat up. Yeah, and then this module, yeah, it will be somewhere here in some way. And I don't need the actual USB port, because I will have it connected to the terminals instead, a wire. And this is fairly long wire, so I can cut it wherever I think, and we'll tap in on it with this. So I believe I can let's see here, if I yes. Now these are fairly long, but let's cut this open somewhere here in the middle, like that. And we shall strip these. Like that. And so that's that. It has to go in parallel with this, but then also this wire, and so I will cut this here. The plug here, well, I can of course leave some like that in case I would like to have a plug for later. Let's see if that's enough or not. And we shall try to do a three-way connection here. So these two and this negative. All of these together. And then put a heat shrink on it. Like that. And yeah, but actually before I can do that, if I'm about to get this through the hole here of this device, I will need to insert it through it before I do this, don't I? Yes, so maybe I was a bit quick here. Actually I need to drill a hole somewhere here. So let's say that this we have a lot of space here to put this module somewhere here. Maybe we could drill a hole over there. And the question is then, how large hole do I need? Well, let's first undo this. So let's see here. $11.4 it seems, and then the outer case is 13.8, so 11 millimeters or so I need to drill. So let's attempt that. I will. Okay, so I don't have any mini drill, unfortunately, so I only have a large Bosch kind of drill that looks like this, and it's not cordless, so it looks like this. So this will be a challenge, and it weighs a ton. But yeah, we can see that there is a pretty good spot here. There is some mark in the plastic. Maybe we can sort of create a hole there for this to go through there. Now, this will be a bit of a challenge. I have some drill bits, but I don't have any 11 mm ones. So the largest one I have is like 6.5, it looks like. But here I have something that's a bit thicker, maybe. Maybe they're not in the right positions here, but if we check this one with the calipers, that's 8 millimeters. But we'll have to do this in a few steps, I suppose. And I could, of course, just start somewhere like this, maybe, just to get the initial thing going. And something like that. And I don't need the hammer mode, no. And forward drilling, okay. So yeah, I will try to hold this steady. Yeah, so that only took a couple of seconds, and there's not much plastic trash. Now let me switch to a slightly larger drill bit. Yeah, a little bit more stuff. I shall empty that, and some on the drill bit itself. We do have a hole. It looks like this from this side. Alright, I will once again change the drill bit to something even larger. Yeah, it was very quick, but it torqued out on me. But I think we got the hole. I shall remove some debris here. Give me a second. So we do indeed have a hole, and it's round, sort of. Let's see here. So yeah, I would need to, but it's still too small a hole. Yeah. So allow me to. Well, this is as far as I can go right now. I need to buy some drill bits, I suppose. So for you it will be a second or so, but I will have to go and purchase some drill bits. One moment. So I remembered that I had another kit actually with drill bits, and that kit had a maximum size of a 10mm one. So yeah, let's go for the 10mm one and then see if we can make that connector fit. Right, let's go. Okay, as you can see, it sort of started to spin. But we managed to make a hole, or make the hole bigger. Let me just remove some debris. Well, it isn't particularly round. Maybe I need to work it a bit more. So let's see here. What's this one? Yeah. Yeah, we're sort of getting there, but we still have a bit left to go. I wish I had a vise or something, but I don't. So and holding this with one hand and this one with the other hand, it's, you know, it's like set up for disaster. so let's go. Let's go for that. So I'm trying to use the side of the drill bit to make this hole larger. I'm not sure if I would call that a success, but yeah, almost. Yeah, it. Look at that. So the first part is in, but then we have these rivets, or what would we call them? And we need to expand the hole a little bit more to be able to push those through. Okay, so I will have to continue using that drill bit, I suppose. I don't have too many options. As of now, this is the largest one I have, so. Could this be it? This could be it. This could be it. Yeah. This is pretty flush. Let's bring in a bit more light here. Yeah, maybe. Yeah, that's pretty nice actually. And then we get like a hole here for the connection. So, and then this nut will have to be fastened. Maybe this won't be too easy. I'm glad the hole wasn't too close to this plastic bit. But alright, I think I managed to get it in place. And this sits pretty snugly. Yeah. Alright. That was a bit of work, but I think we managed to do it. Great. I think I need to... I mean, we can do the soldering stuff now, but before that, I think we need to... or I need to at least get this dirt out of here. So give me a second to bring the vacuum cleaner. Much better. Indeed. Nice to have a clean space again. Let's see what kind of stuff I had. Some heat shrinking tubes. And the screws. Alright. Well, having my handyman abilities in consideration, I would say this is a success. So, yeah. Okay, so what we want to do now is, yeah, I want to clean that out with some high pressure air maybe later. We'll have to drill another hole, I suppose, for this USB-C header. And but that one should be connected to these terminals. But yeah, we need a hole for that as well. But what we could do is we could solder these wires first. So, like I showed recently, we would like to basically connect these wires, and also let's see here. No, where did I put here? This female connector end. So they should all be pretty intertwined, and because this will go to the cell like that, and yeah, we want all of these to be together so that everything from here is fed directly into the cell or into the light, so to speak, but in this case we want to feed the cell. And I looked it up. Well, this component here, this is a diode, so it should prevent any current from going back into the solar panel. So we should be safe here to charge the cell, because the solar panel is doing the same thing basically anyway. So so yeah, And then where would we put this one? And I will need a nut for this one as well, so let me find some stuff. Right, so I have the rubber gasket. Thing. There. And then there is this nut, once again, that should fit onto there. Right. Let's just try to place things out here a bit. So this chip could be somewhere here. So the output of this chip should also go to the battery. Yeah, and then this one, it could be, well, we could place it close to the other one, or we could place it in the other end of the, somewhere here, and then these cables will be soldered to the circuit board. Just separate the two interfaces. Maybe that's a good idea. Yeah, this will go there, and the output of this should be go to the lithium cell, and these should also go to a lithium cell, because we will use an external cable for the DC plug already with such a chip. And then yeah, all of these have to be connected, right? So yeah, we don't need to connect that directly to these leads, so we can leave that for a moment. And see what we can do with this. I will need to strip these. And I have a better already stripped version here, so I can remove that one for now. Yes, let's have a look. So all the red wires, maybe we should strip these a little bit more. Maybe that should do the trick. And then let's start with the red ones. This one, and then this red one. Maybe I can get a helping hand. Yes, and then all these black ones. Alright, is this correct? So this will go somewhere here, this will go in there, and this will go to the cell. Maybe. And then I will need some heat shrink tubing, maybe. So yeah, I think we can solder these onto here and get that done. Yeah, so I will preheat the soldering iron and we are good to go. Okay, so I have gathered some things here to solder and the soldering iron is heating up. So yeah, let's attempt this. Maybe I'll fold this as well. That way it will be more evenly thick maybe once we get a solder blob on it. And can I use the helping hands maybe? Yeah, maybe. So let's inspect this. Well, we have a decent blob. All the wires seem to hold on pretty well. So yeah, great. Now let's put some kind of sleeving onto them. This should be sufficient, and then somewhere around here I have the thing, so I can maybe I cut it a bit too short. Yeah, I think I need a little wider piece. Like that. Yeah, this feels a bit large on the other hand, but okay, maybe I can move this a bit this side, and then I will heat it with the side of my soldering iron. Like that, and then we can put a second sleeve. Yeah. So this shouldn't short anything out, I hope. And then we can do something similar with this positive side. Yeah. All right. So okay. And well, now then, this will go. Let's see here. Now I have a bit of a mess, but we should manage. This should go there. This should go to the cell. And this should be somewhere around here. So yeah. Have to find a place where to put all the leads though. Maybe I can stuff them in there. And this should have some space to in the top lid. So I hope that this will work. Yeah, it should be fine. So that's good that the height wasn't a big problem, a big issue here. And yeah, maybe we can fasten this one here. Perhaps Yeah, put some sleeving onto it as well. Maybe. So that it isn't a bare circuit board in case it falls off. I'm thinking that I should fasten it with some hot melt glue maybe to this, but maybe if I put a sleeve on it of heat shrink tubing as well, then that would be nice. Yeah, so and then the USB-C interface, which should be connected to these terminals. So yeah, it could be here where we have a little mark. Maybe a bit off to have some space to rotate the nut, which would struggle a bit here, but it was okay. So yeah, we have to drill a new hole. I believe this marks the spot. Pretty much, at least. Now, I think that this is not as thick as the other one was over here. So I'll have to re-measure. Let's have a look. Yeah, 10.5. So the other one was 11 or so. Just above 11. So maybe a millimeter thinner, this one. Okay, so let's try drilling once again, and over here then. And maybe I will try directly to drill with the 10mm one. Yeah, let's go for it. Yeah, so I did get a bit of a cut here, but it's not deep. So yeah, but I will. It wasn't a very good idea maybe to try the 10mm one at once. So I will take some gloves here and try again. Maybe I can do it like this and hold this down. Well, that was faster, if nothing else. Maybe safer. So yeah, safety. This one. Well, it almost fits right off the bat. So maybe I'll need a little bit more. will close off this USB-C port with this rubber seal. Yeah, seems to fit there snugly. And yeah, just allow me to clean up this mess and use some high pressure air to remove all the debris. So I'll be back in a moment. Okay, now to the applying this bolt to that USB-C header thing. Let's see if this will align better. Yeah, it sure certainly seems so, at least. This won't go anywhere, and we have USB-C and DC plug on the other side, both with rubber grommets. That's pretty good. So I would need in order to place this somewhere and not having it short out, I want to place let me have a look, a large enough, have a look at these. You can take a green one since this circuit board is green. Maybe we can follow the same theme. Let's have a look. It's a bit too tight, so not that one then. This, I believe, is the largest size in this bag, so we don't have any green. Okay, we can take yellow. Why? Because this one's yellow, so it will work well with that one. If this fits. Yeah, that fits better. So I'm thinking we could do something like that. And solder these and then heat shrink it, and yeah. And also we should note that we have the LEDs here, so before we close everything up, maybe we could just expose the LEDs by cutting out a little, doing a little cutout here, perhaps. So yeah, I need a pair of scissors. Okay, so maybe something like that. And then I will slide over here so that we can solder these. And let's see here, not to mess up the positive and negative. I think that would be unfortunate. So I hope that the red one is positive here. And also on this we should do some measurements to see. Yeah, I should have done that previously, but yeah, let's do some measurements first, just to be sure. Let's see here. Continuity. Right. So I want to test if this is a center positive or not. So I will try to. I can first try the negative side, the casing, and go for the negative here somewhere. Maybe over here. So yeah, does seem to be negative, and then the positive. Yes. So that's good. So this is center positive. And now for the USB part. So the casing inside here should be negative. Let's try. Or so I thought. Okay, but we can put this to volts instead, and we could grab USB C lead. I might connect it to my USB charger. And not shorting these out, connecting this to that port. And now let's measure the voltage. So we are in voltage mode, and if we put the negative to the negative, or what we think is the negative, the black one, and the positive, yes, we get a positive 5 volts. Okay, that's good. maybe we should try to connect the cell and see if we can give it a charge through the USB-C port, because that goes through the actual charger. So let's try that then. Does it actually work, first of all? Yeah, that's a good start. Now I have the other end of this USB cable connected to a USB charger, so and let there be light or something like that. And actually it's visible through this, so we could we don't have to do any cutout. I wanted to do a cutout for the LED, but I suppose we don't have to. So my watt meter is showing 9.3 watts, 9.2, and if I disconnect, we go back to 5.5 watts. I have my phone connected to it also, so. All right. It does produce a little bit of heat, actually, this one. So maybe it shouldn't be too closed off, but the current should be reduced quite quickly, so I will just try to do something. Yeah, not too much, but just so that it isn't shorting anything out by default if it comes loose. So yeah, it did heat up a bit, but not too much. But I've only had it connected for a little while, but yeah. So okay. Before I place everything inside again, should I reconnect? Let's say we have the solar cell connected as well. And just to make sure everything still works, we can use our special lead. So I should be able to zoom out a bit first, and then connect it there. And then connect the cell. And we can measure some current. So I can put this to the milliamp range. And if I use this light to shine on that, so nothing. So have I done something wrong? Oh yeah, I have done something wrong, but not what I thought. So I didn't place this in the milliamp slot, at least. That's one thing. Yeah, 45 milliamps. Seems to be working. Okay, that's good. Disconnect the cell. Okay, so that's at least a good thing. Now we can remove this maybe. So what is left to do? Well, putting some hot glue maybe, and fastening this over here somewhere. Maybe put some hot glue. Yeah, and then connect the cell to this one. And then we will create we'll create a lead for a center positive one, hopefully, for this connector, which should be already going through a charging chip circuit board, so we can have external charging if we prefer that. So yes, great. Let me bring in my glue gun. So I got an idea. Since these things can get a little hot, I'm a bit worried about the one in here, but okay, maybe it will manage. This included cell, if you only have it like a 1 amp hour one, it should lower the charge current pretty quickly, since the voltage of this should rise pretty quickly, and thereby should produce less heat. But for the external cable that will use the DC plug, I'm thinking it'd be nice to have a little project case for this TP4056 USB-C board, which would have the added feature of a small fan. Now I have such a translucent brushless 12-volt fan, just a generic from Temu or AliExpress, and well, I'm kind of curious if we could yeah, somehow fasten this to the project case. And as you can see on these little modules, you have two inputs, USB, and then you also can tap in via just normal wires. So we should be able to sip some power from the charge circuit itself, maybe. So let me connect this. We get a blue light and a flickering red light because I don't have any battery connected. So we watch this one while I carefully try not to do anything too stupid. So I have the positive up there and a negative here. Let's see here. Yes, I have the negative here. So I should be able to yes, we can see the fan is spinning. It won't move a ton of air, but I don't think that's needed. So yeah, that's one plan to make sort of a project box which would allow for a fan like this to blow some air in and then have some air come out somewhere. So let's look at that, if we can manage to do something like that. And yeah. Yes, but let's leave that to the next part, because yes, there will be a next part. This video is almost 2 hours long or so, and while I'm sure it's very interesting, I think that it's time to split the video here. But we've established some great things, and well, for instance, we've seen that the cell is taking a charge through the solar cell, and it should charge through the USB interface. So let's leave the external charging box stuff for next video or the next part in this series. And yeah, I think it has been a very interesting project so far. I hope you enjoyed this video and that you enjoy this series. So don't miss out on the next part. Thank you so much for watching and see you all in the next one. Bye bye.